Hello. Okay, there we go. That worked that time. All right. Thanks for coming, everyone. How's everyone doing tonight? Pretty good. Okay. I'm Ray Ko. I am open source software technology solutions professional on the global black belt team at Microsoft. Whatever that means is up to you to interpret. Basically, I work on our cloud platform, Azure, as the open source guy for all of Canada all up, along with our global team. So I'm here tonight to talk to you about containers. Who here works with containers today? One, Nail, someone with a shaky hand back there. So no one. Awesome. Okay, I wasn't sure what the audience is going to be like tonight, so it's a pretty high-level overview. Please interrupt me at any time. I have no problems with that. Ask any questions you like, and hopefully you get something out of this. If not, come talk to me after and ask me what you want. So, containers. Containers mean a lot of different things to different people. For some, it means technology called LXC. For others, it's something called Rocket. For the most part, when I do these presentations, I talk about Docker. Who here has heard about Docker? Okay, awesome. So Docker is pretty much the company that's popularized containers at this point. It's kind of like the de facto standard. Is it the best? Not necessarily, but I mean, best is a definition left up to you. In fact, that it's most prevalent, probably is the best definition of best. So that being said, where do containers fit into the whole ecosystem in terms of DevOps? And it's really, for the most part, a DevOps sort of thing right now for most companies. If they're not doing, well, that's not too early. All right. So it kind of fits into two different parts of this whole puzzle. The first one is in your sort of developer environment, sharing your application, making sure your system is exactly 100% compatible with your team's system. And the reason behind this is because containers are your fully packaged environment for your app. It contains sort of the OS, all libraries and binaries you may need, as well as your custom business logic, your Rails app or whatever it may be. So, having said that, the next point you would probably use containers is deploying from your development environment to production at some point. And there's a whole workflow in there in terms of doing your CI/CD stuff to ensure that everything's being tested and validated and so on and so forth. Now, that being said, I also mentioned containers, you just package everything together and share it with your dev environment. Like, a little earlier than what I expected, but isn't that just VMs? Like, yeah, but no. And it's like a very consultant answer, and it gets kind of technical. So they act very similar to VMs, but containers are a whole other beast. And there's a scenario where you use containers, and a scenario where you use VMs. Which one is really up to your whole system? So again, that's like consultant sort of answer for you. At an overview, this is sort of the main difference. And what it boils down to is that VMs have a lot of overhead. So this kind of eye chart kind of summarizes that. When you take a look at a VM, right, you have, for the most part, your bare metal server with an OS and hypervisor, some sort of VMware, Hyper-V, so on and so forth. And then you have a self-contained, the idea of a container in the VM world, right, where you have a packaged application, a whole OS, and it also virtualizes the hardware and has a guest OS in there. Now that has a lot of, you can only put so many VMs on there, you're not really going to get the most efficiency, you're essentially virtualizing your server, and it's great, but you're not going to get the maximum efficiency in terms of like, total number of IOPS and that kind of thing, and maxing out your penny, especially when you're talking about working on, Azure or AWS or DigitalOcean or whatever your cloud provider may be, or even on-prem, on bare metal servers. The other argument for containers are they're isolated, they share an OS, and where appropriate, binaries and libraries. So if you take a look at the overhead between the two of them, they're like day and night. Like it depends on your setup, but it's an order of magnitude smaller. What happens is that the Docker engine itself essentially shares a common kernel for all your containers, okay? And then, you might have, so it was built mostly for Linux kernels. Now you'll see Docker for Windows or Docker for Mac, but essentially they're running a very scaled down Linux kernel underneath the hood for everything. And then if you need to run like Ubuntu or CentOS, it uses the kernel and then it fakes the actual specific OS environment for you. So the container thinks it's working in Ubuntu or CentOS, but really it's not. And where it has the most amount of power is that all those shared resources are read-only, so it's only loaded memory once. You make references to a file, and it's far more performant in that sense. There are security issues and things like that. We'll get into that in cons later on. But essentially what you see is very similar stack, but much more scaled down. So instead of having a copy of the binary multiple times, these two apps, for example, share the same binary. The Docker engine runs the kernel, and then really all you're putting on top is your app, right? Instead of packaging an entire operating system, virtualizing the hardware, loading it, load times, it's a bit of a pain. So again, benefits of containers: consistent self-enclosed environment. It's reliable, so you're always sending off the same things. There's no sort of incompatibilities using the same engine. You're not, running a VMware virtual machine versus some other platform. Portable, it's much smaller in terms of VM images. You're using shared resources across containers, so there's repeatability. You're not repackaging the same thing over and over again. You're sharing it and running two VMs with the same copies of different things, right? Running at the same time. CI/CD friendly, so what that means is that you can actually script your containers. So if you make a change, instead of rebuilding the whole virtual machine, you're only rebuilding that particular chunk of your container, and then everything kind of versions itself upward, right? So patching is a lot easier. Fast boot and load time, seconds versus minutes or more, depending on what your VM setup is like. And this goes back to the fact that containers are in fact all files, right? Like how long does it take for you to load a file or like a daemon on your machine versus loading an entire virtual machine, memory, virtualizing the hardware, so on and so forth. Another big benefit of containers is that it's distributed imaging, right? So kind of think of it like GitHub for your virtual machine, right? But much later. You make references to other packages and it brings it in for you, and if you don't already have it, it pulls it in from Docker Registry or Docker Hub, and it packages it up and gets loading for you. Okay, so some terminology to get through: Docker file versus Docker image versus Docker container, or some kind of configuration file, some sort of image. You're going to hear virtual image, virtual machine image, container image, and then also the actual container itself. So a Docker file isn't unlike, your, let's say, package.json file if you're running Node, right? It says all the different libraries you want to bring in, what's required for your application itself. It also includes the instructions to build the container. So you can sort of import Ubuntu to start off with. You run the next line to run another script to include or run, let's say, apt-get install node. I think that's the command now on Ubuntu, to include node onto your server. And so it's kind of like, if you work with Vagrant or anything like that, it's kind of like running through the config of how you build up your virtual machine. The difference is that this will, for each line, it'll create a snapshot or a cache of that particular part of your container. So if you have to run through and rebuild it, if you already have a cache at a certain point, it won't go through and rebuild to that point, right? It'll just reuse that snapshot and then build on top of it if you haven't changed from that point onward. The image itself is actually the shareable package object. So while we have a Docker file and you run through, it'll run through and build the image itself. And then the image is the piece that actually gets distributed and shared among your team or globally to other people. So the image file itself is, you can think of it as like the, in a way, the GitHub repo for the project, right? Project itself. And containers are the actual running instance of an image, right? So that's the relationship between all of these. So the container itself is what you would actually go and run like a Docker run, and then your container package itself, and it'll be up and running. So the whole point of containers is this idea of like pet versus cattle scenario when you're talking about your infrastructure and deploying your apps. Pets, generally, you care about. You'll hear this one a lot. I don't really like this one myself personally. It's kind of violent, but So your pets you care about, right? You name your pet. If it's sick, you take it to a doctor. Like you're up at all night, you're like worried. You know, you get a call, server's down, you're like freaking out. You're like, what's going on? You know, you spend time caring about it. Cattle, not so much, right? You don't get attached. You don't name them. You know what's going to happen to them in the end, right? So if it gets sick, you're like, oh, I got another chicken, no big deal. Same thing with containers, and in a way that's what virtual machines were in the past, but you know, you kind of care about them, especially on public cloud for the most part. So, you know, they're ultimately replaceable. Same thing with containers. You generally don't really care about them. So in the grand scheme of things, where does this all kind of fit in, right? So your bare metal your bare metal server, your on-premises server is sort of like this mansion, right? You're like Tony Stark living on this fake Malibu cliff with this like pimped out building. You've got like 4 car garages. Why not? I might need it in the future. Who knows? Swimming pool, so the whole shebang. VMs are more like these townhouses, right? They're not bad. They're nice. It's like it's my house. I care. I know who my neighbor is. I care if one gets burnt down or someone leaves the neighborhood. Containers are more like apartment buildings, right? You don't really know your neighbor. Like I lived in condos before, and I don't care. I'm just in and out. If they leave, I'm not too sad. Someone moves in, and now with Airbnb, it's just kind of like in out, in out, in out. You don't care. So this brings me to the whole idea of scaling out real quick. The whole point of containers is that you want your applications. This is really good for apps that are stateless and so on. We'll get into that in a second. But again, you have this Docker file. I don't actually think it's YAML. That's long. So you feed that into the Docker command line. It reads it, builds the images. It sends it out to a registry of some sort. What you see on the second line here in terms of the swarm is Docker Swarm. It's their way to orchestrate or kind of manage all these containers in your giant, massive fleet. And once it's out to the registry, then you have a way to call on that file, load it onto various machines, whether they're bare metal servers and you're just kind of filling them capacity, or if they're VMs themselves and you're trying to fill capacity. It doesn't really matter. We'll take care of it for you. And then you have these services arranged inside these Docker applications, and you're good to go. So the whole point is you're trying to get to the whole, containers at scale, clusters at scale. So it's the same principle, and I prefer this terminology a little bit more than the whole pets versus cattle. Building out your whole city, right? Like you want to make sure you have the highest density per square foot or per performance of your machines as much as possible. So you erect these massive buildings. They're tiny. They're only really good enough for the purpose built of housing a couple people, that sort of thing. And it's massive hyperscale. And you can kind of see a new trend coming up to these pop-up stores using actual containers, right? Same kind of idea. You kind of plop them down, share resources. If you think about like mansions, this is a massive footprint of a building that has probably 8 hot water heaters and its own plumbing and stuff like that. Houses are a little bit better. Condo buildings are more efficient. These container parks are hyper efficient, right? Like you're just running electricity. No one has a washroom. You're screwed if you got to go to use something. You see the food scene doing the same thing. Shared eating spaces. You can plop one down. You can have a pop-up restaurant. They close down. No one comes in. So on and so forth. So how does it all work? So containers are ultimately just files, right? So it's not new technology. Like we mentioned LXC earlier. It really runs on the principle of Linux namespaces, or what do they call them back in the day? I forget. Since they're just files, like how fast does it take for you to load a file, right? Pretty fast. How long does it take you to have it daemonized? Also pretty fast. Virtual machine, again, not so much because you have to boot up a whole virtual environment, hardware, so on and so forth. Container engine makes the app think it's running in an OS, but really it's not, right? So again, it's just references to files, it's got the underlying kernel, it's got everything running for you, and it's all in memory without having to boot up a whole virtual system. Shared resources are just read-only, so again, maximum performance, and again, biggest thing is less overhead, right? So it's not a VM in that sense. So it's really great for stateless services. So ones that don't have to really persist any data. So not persistent activities, the front end to a web app, for example, fantastic. Hyper horizontal scaling. So VMs are kind of meant for this, for like scaling, especially on cloud infrastructures. But again, far less overhead. Repeatable and consistent packaged apps environment. So if I give you my Docker image, first of all, it's lightweight, and second of all, we're guaranteed for sure it's going to run 100% every time you're going to run it, right? VMs can hit this sometimes. So basically, it's really great for microservices, this hot thing microservices, which is SOA, but just it's the modern implementation of it. So problems with container, data persistence. So it's really great for these stateless apps, but not great for ones that need to save data. Let's take, for example, databases. Terrible. Well, not great. I don't want to say terrible. The problem is that what you end up having is that you can't, because you're building these like massive cattle farms, right? And you're not attaching them to any kind of real meaningful names, and then you gotta keep track of all these massive number of cows that you have, or condo buildings, I prefer. And then they go up and down. Like, where do you reattach your persistent storage, right? Like, which one goes down? Where do you lose data? It becomes a bit of a headache. There are concerns about security, kinda. It's not that big of a deal, in my opinion. It's kind of hard to crack. People say that hypervisor, it's much harder to get to that level to attack versus an entire kernel that's being shared across these containers. If you're good at that, you're making lots of money. Other things, there are other problems that's not a very helpful statement, but the one I want to get to, and the biggest solvable problem, is orchestration. So because you have this massive fleet that's basically a stateless app, how do you basically traffic that, that data or those requests? So this is what orchestration is about, and how do you basically plop down your service onto the right machine that has enough resources still, right? Because I'm saying that containers use less resources, but it still uses them up. So how do we maximize the entire fleet? How do we not overload or underload a server? And these are the problems that we need to solve in the end, and this is an easy one. So this is the idea of orchestration. Like, you go and this section plays, and I don't know how to play music, so I don't know if that's actually how it goes. And so there are different products that are designed to solve this, right? You hear of Docker Swarm, which is Docker's implementation of this. It's kind of weird. They were the ones who kind of like popularized containers, and yet they're kind of a little more behind. There's Mesos, which is an open source project by Apache, which then feeds into Mesosphere or DCOS, which is an orchestration tool. And, it's a little bit more complex than just that. And then there's Kubernetes, Google's version of it. There's like so many different ones out there, but they're ultimately trying to solve the same problem. How do you get to these machines? How do you deploy them? How do you make sure you keep them nameless, and yet you still know where they all are, right? So this is the state of the whole ecosystem. And the problem is, there's different tools. They kind of operate on different levels. You have ones like OpenShift and like Cloud Foundry, probably the top-ish. Orchestration like Kubernetes and Marathon and the whole sort. So this is kind of a messy kind of ecosystem, but it's all there for you, and there's different companies solving it. So you have your different engines again: Docker, Rocket. I'm not familiar with that one at all. And operating system layers and the whole whack and shebang. So again, the ultimate goal is to be able to make all this kind of crazy mess. We've gone kind of simplified things in containers, and yet we've created a brand new headache for ourselves, right? This is only 6 servers, but in theory you could have hundreds, thousands of servers themselves with tens of thousands or hundreds of thousands of containers running the application in mass scale. And the whole idea of orchestration, you can build it yourself manually using Nginx and being able to map that to a particular IP address or on a particular port on the server, because you can have 3 of the same app running on a server, each one requiring access to port 80, but only one of them really can have access to that at a time. So how do you remap that on the server? And the orchestration takes care of that for you. This is I don't know why the slide is here actually. This is the difference between the two of them, a lot of overhead. It's a little bit easier to orchestrate, I guess, in this sense on the VM because you're only limited to so many virtual machines you can shove onto a server. And as it relates back to the ecosystem, right? When you're trying to work at scale, you need to have the pipeline, right? So that did not go. All right, you need to have the pipeline that feeds from your development environment. You're testing that. You're running the actual application. You basically check it into a repository, make sure it runs through all your tests through Jenkins and so on and so forth, making sure it's perfectly good. Build passes. Now you want to go to deployment. How do you orchestrate that piece? How do you reconfigure even the virtual machines or the actual bare metal servers themselves before you actually launch containers? And then once the containers are in the environment, you have to make sure that they're running. You got the blue-green scenario and so forth, right? And then of course logging is another big problem with the platform. I have more slides than that. But that's the container sort of ecosystem at large in terms of how it's trying to set up and solve the problems. I had another slide which just jumped to questions. All right, I'm missing slides. So yes, it's up to questions. Question?
Yeah, what do you use for monitoring your containers?
So myself personally, I tend to use DCOS. What it's really great at is it gives you the good UI. It also comes with like something called Universe that you can install. Basically, it's like the marketplace, if you will, for other containers. So if you wanted to, so you can have DCOS will spin up the VMs for you. If you wanted to do that, it'll deploy the containers and kind of load balance where they go, right? Making sure that you're maximizing idle servers and that sort of thing, and direct the traffic to them. And then,
Actually, the question is how would you monitor your containers? Like how much memory they're using, which one is overworked, which one is long, which one is down?
yeah, so DCOS. So that'll manage it all for you. So it actually listens to the state of all your VMs and your containers. So it'll ping it every so often. I think it has it's essentially like 30-second ping. One time it'll flag it. Second time it'll be like, okay, it's probably down. Third time, if it's still down, then it'll just take down that container, rebuild it. So that's why it's cattle, right? Like I don't really care. Like I'll look at the log file later, just kill the machine, solve it, and then if there is a bug that I can really fix, then I'll just rebuild the container, go blue-green scenario. Once they're up again, take down the old ones. Yeah.
So you mentioned Windows and OS 10 versions, and I was wondering if the abstraction is still to be either in Ubuntu or CentOS box.
So the question is, I mentioned Windows and OS 10 Docker, and whether or not the abstraction is still CentOS or Ubuntu.
Yeah.
So Docker Engine actually runs on just a vanilla Linux kernel, right? So that's shared across most different flavors of Linux. So when we talk about we're using Ubuntu versus CentOS versus Mint, my mother's Linux flavor, it's all just using that kernel on top and then faking the individual Linux itself.
So what about under OS 10 or Windows?
So Docker Engine package itself with the Linux kernel, so that it's separate. It's not borrowing your machine's kernel. It's running its own Linux kernel.
So it's a VM.
Yeah. I mean, I don't work at Docker, so I don't think they say it's a VM. It's an engine,
Yeah.
but it's probably virtualizing. Yeah, in that scenario.
Okay.
Yeah.
So that brings the question. Why would I use Docker versus say one of the VM implementations for Windows, for example?
So it really boils down to the fact that you are, so on Windows itself,
Yeah.
there isn't a good solution yet. as Microsoft, we are building one that is directly.
VirtualBox, for example. VirtualBox.
And again, you're running a full virtual machine, right? So the virtue of running the engine itself is right now not a good example because it's not built for Windows. You never use it for Mac because they're not going to get there, right? But Microsoft itself has dedicated resources to build Docker natively on Windows. So you can actually use the Windows kernel and then basically take advantage of all the lower level extraction.
So that brings the next question then.
Yeah.
Your scripts for Linux implementation are not going to run on Windows then. If your Windows implementation is taking advantage of the underlying Windows APIs.
So it won't be taking advantage of all the Windows APIs. It's just like the kernel itself. So when you're pointing to like Ubuntu inside the Docker engine, it's not running the full environment. So when you're writing natively for like a Linux environment, it's just going to run it as if it was in the system and then manage all the lower level like networking and all that to the kernel.
So it's actually translating that to Windows code.
Yeah. I think the reason why we're committed to it now is we just released the Ubuntu Bash, and that's sort of like the subsystem. I think they're basing it off that, but that's just my thought on it. I don't know about the engineering team. But if you have more questions about how that actually gets implemented on Windows, give me your contact and I can give you the engineers.
I'm just more interested in compatibility, really. Like if I take my Docker image, right, and just say I want to run it on this Windows machine, is that a yes?
Yes. So the Docker image, again, because it's on the Docker engine, will run fine on Windows machine. It's just not taking advantage of the Windows kernel at the moment.
Okay, well that answers a lot of questions right there. Because to do that, you have to do certain virtualization.
Yeah.
Okay.
Yeah. So probably does virtualization. I have no idea. Yeah. Any other questions? This one first. Yeah.
Hey, what do you do for persistence? Let's say I put up a microservice to interface with the Shopify API. I want to do a bunch of logic around data that Shopify has.
Yeah.
At some point, I want to save that result. Would you generally have the calling party save that data, or would you have the Docker image itself interface with your database?
So the question is about persistence and how you would persist your data. If you're working with like a third-party API, like Shopify's, and how would you end up saving? So it depends on your setup. If you have to save it to a database, you'll have to probably make it a call to something that's outside of your container swarm, right? Your whole cluster to your actual database service, right? And every application that you write has to call on that, right? And that relies on your internal TNS. That's one scenario. If you're saving, let's say, let's see. So your scenario is Shopify's API. Let's say it's somehow some customer data, right?
Yeah, like
You
like
make Shopify.
value, for example.
So, I mean, I'm not familiar with Shopify API, but do they end up saving it for you? Like, is that an option?
I would save it to a cloud hosted database.
Yeah, so like ClearDB, that sort of thing?
Yeah.
Yeah, so that's outside of your swarm still, right? So your app, your business logic itself would have to handle that data and save it outside of your cluster. So again, it's not great for like, if you want to like scale like massive database system using containers, not there. You can mount a volume, but then the problem is once that container goes down, like you gotta configure that exact volume to be remounted to a new container, and it's a pain in the ass right now. Yeah. Another question back there. No. Same question. Okay.
Did you purposely wear the opposite shirt?
I own pretty much like 3 shirts, so it's like 1 in 3 chance that I'll wear the Yeah. Good question. Yeah. Yeah. I wash them though, so we're good. Yeah. I think. Yeah.
So got a recommended distro for a Docker?
Do I have a recommended distro for Docker? No, because you can run pretty much any distro. The best ones, of course, Docker Hub. You can always search, just like on NPM, you can search for the particular distro, and there's like 18 of them. Some are more secure than others. Some are more trusted than others, right? So if I make a distro for you, probably don't want to use that. But if Canonical has like Ubuntu, you can trust it. So, I mean, I would go with the latest one possible, right? So what's the like CoreOS is pretty stripped down comparison. Go with that. Yeah. Fine.
Okay, right?
Yeah. Thanks.